Alright, so we're back at the surface. This is the surface with the issues of not turning on. AC in signal not available. So we're gonna see what we can do on this guy. Okay. Just recapping. That's the screen. All good, original condition. No damages. That's the most important part. Okay. We'll have to edit the video here. Okay, we've got our heatsink, keyboard, and our beloved motherboard. And what I've got here today is a battery which I wanted to test. I want to test this battery out, just learn a little bit about it. Okay, so this is a brand new battery, and let's see what happens to this guy. Okay. Voltage mode. Let's see what the battery voltage is outputting here. So this battery is not gone into a protection mode. Good. Whereas the other one has. Okay. That's what I wanted to rule out. I suspect this motherboard may need a battery to work with. I don't know that. Just an assumption. Now, this battery, let me have a look what's happening here. Okay, we need some tools. Using my new organizer. Okay, let's pull that out. I did put one screw there. Okay, I remember. Okay, so we got the motherboard out. Let's keep him safe. And so I don't trust myself just putting in the battery, because I may not make the right contact. Let me see, can we gamble on it? In fact, we can. Perfect. Okay, just like that. Okay. Okay. Son of a bitch, there's another one on the bottom. Okay. Maybe we can just ignore that one, okay. Because we need to return this battery, most likely. We're doing this only for testing. That's why I don't want to remove the plastic. It's just making it difficult to put this guy in. You wanker. Okay. There's a noisy Indian miner behind me going mental. Fucking hell. Okay. Okay, let's see what happens. Out of curiosity, see what voltages are present on board. So we've got battery voltage and batteries charging. Is it? Yeah. I can see the battery being charged at the moment. Okay, so something's happening to the battery. Okay, still no power. Remove the charger. Power button. So we got 3.3 as before. Any other voltages present? No. I don't think we have AC okay. Hi, Kevin. Hey, Kevin. Yes, Kevin. Yes, I am. Thank you. Thank you. Thank you. Bye-bye. So, no success. So battery, their battery is in protection mode. This guy doesn't want to turn on. Hi, Marcus. Good buddy yourself? No, I was busy, mate. I don't know. I couldn't get to the phone. Sorry. How are you? Okay. Yes. Okay, so what do we do about this job then? The battery is not the issue. So this laptop does not need a battery to turn on. We've concluded that. Yeah, we're going to do something crazy now. And that is apply logic voltage, maybe 1 volt, 2 volt, maybe 3. On the AC OK signal. Not something I want to do, but I don't have much choice at the moment. And we'll see what happens. If something fries or not. At least if something fries, then we will know what fried. So this is a Surface laptop 2. Okay, AC in, we have, now we're looking for AC OK. Charger OK. How about AC in? Which was pin number 19. So basically, one of the main issues okay, so this MOSFET here is not giving AC AC in signal. It's not coming in. It's being pulled down. Okay. Pin number 5. Alright, so what we're going to do is bring the charger in. Okay, we're going to now connect the charger. It's connected. We're in DC mode. So pin number 5 of a MOSFET, where the AC in comes from, that is over here, which is the voltage of the charger, which is fine. So comes in, charger voltage in, let's have a look at this other one, Q63001. Which is that guy there. One and 2 should have the charger in voltage, meaning there we should have the charger in voltage, correct? So there's no issues there. The big coil here has at the moment 0, okay? So not a big deal. It's currently not being told to be maybe turned on. And it goes into the rest of the system, into battery charge controller. Okay. Pin number 19, AC in. Pin number 19 of our chip. We're not getting the 19 volts. See, that's the problem. See, here to here. We don't have our 19. Now, AC in. Okay, let me check that pin. Again, I'm going to check the schematics of this one more time. 9237. Okay, so we got it now open, and AC in. Adapter voltage sense. Use a resistor divider externally to detect adapter voltage. Adapter voltage is valid if the AC in voltage is greater than 0.8 volts. Okay. Now pin number AC in maximum voltage is 0.3 minus 0.3 to plus 6.5 volts. So what I'm going to do is this. I'm going to actually apply voltage. And so I'm going to cut the power, run in continuity mode just to confirm that I can run a wire maybe from here. Yeah, good. We'll run a wire from here only, and let's see what will happen. We should have that tiny magical wire I used yesterday. Okay. Alright, so what we're going to do, we'll get a sharper needle. Hello, SureCan speaking. Very well, you? Yeah. Oh, you better talk to Tycon about this. Yeah, I don't really know much. I just go for the big brands like LG or Samsung or something. Yeah, yeah. Look, just go for the latest one that you can afford and that's suitable to your size. Should be fine. You don't really need to be concerned much. Just head over to the stores and have a look, compare. Yeah. Sorry, mate. Yeah, it's too big of a field. Yeah. Been good, thank you. Just working, mate. Keeping up, trying to catch up work. Yes, I have. Thank you. And you? I'll send a text message to you. Okay. I'll send a text message to you. You're welcome. Bye bye. Thank you. Okay. Okay. So what we're gonna do now is this. At the end of this cable, we're gonna inject 0.05 volts. And let's see what will happen. Let's try and set up this environment. And Okay, voltage 0.5, enter. I don't know what amp to put in. 2 milliamps. Okay, 0.0 amp, 0.02 milliamps, enter. Okay. Okay, first thing first, see if there is continuity. Yeah, we have. You can hear that? Good. That says that's AC into. Let me double check. Okay, let me double check on the microscope. I don't trust the soldering. Okay, the wire is not very well exposed. Try again. Okay, that's better. Why is he touching? Why is he making contact? That's weird. What? You mean we're touching ground? Oh, we're making contact with ground. How is that possible? What? Okay, let me double check this wire. Desolder this. Okay, maybe this soldering is better. Let me double check. No, we still have a short. Okay, that's very interesting. What's going on? Let's remove that. Do we still have a short? No, we don't. Okay, something not right with my cabling. One sec. What's going on here? Okay, I understand what's going on. When my power supply is off, they're doing a short to cut the power out. Okay. Okay, it's not a problem. Okay, let's go back. Okay, that's done. Okay, we're going to connect this now. Okay, let's see what will get hot. Okay, here is a moment of truth. So what we've done is we're going to put 1 volt, sorry, 0.5 volt into AC in of the BQ chip. And let's see what happens. Now, I haven't turned on the power supply yet. Okay. Now, ready? We might get a fire or something, I don't know. We're going to power on the unit. Okay, it's applying 0.5 volts at the moment. So we don't have 3.3 always on. Sorry, we have, but the board is not currently on. What if we try to jump start? I don't think we'll have the 5 volts, will we? Let me check. We got 3.3 on the power button. It's taking 0.03 amps. It's at 0.16 volts. When I press the power button, it's trying to turn on. Cut the power, 0.5 volts. Yeah, it's trying to turn on. Any power anywhere here? See, we got our power button. in this mode. Let's have a look. Okay, let's see if we can take some measurements. That's the power supply. Okay, that's better. Okay, I'm going to increase that voltage. Voltage to... No, that's the amp. Voltage to 0.7. And still, I think it's being pulled down to not work because of an internal problem. 15 volts here, 0 point something on the other side. If it touches there, it's gonna boom, blow that chip away. It's being told not to work. And voltage for system, yeah, it's 0.02. This board is not going to work with that voltage. Okay, cut the power. So this experiment also failed. At least we tried this. Okay, put that coil back. And once I removed it, what voltage do we have at the AC in? 0. It is being pulled down by this guy. He senses the voltage. Oh, he should sense the voltage. It's coming into a diode. Power itself into a diode 63001. Number 17. into a 1 ohm resistor, which is that one there. Let's cut the power and just check the resistance. Yeah, no problems there. So we should have high voltage on one of the legs. This one here. Yeah, correct. Which goes into DC in pin number 17. So that's not an issue. And VDD what's on the VDD? It should be low voltage, 5 volts. How about number 23? What's the voltage on that? Which is prog hot. The prog hot is currently on. So prog hot, number 23, open drain output. Pulled low when AC prog hot, hash DC prog hot, come on. Or low VSys event is detected. Okay. Now VSys provides feedback voltage for max system voltage regulation. Hello. Okay, so we don't have a solution yet, unfortunately. The voltage comes in, AC OK is not on. If AC OK is not on, that's a big problem. So maybe I can do a search for AC OK on the schematics. Okay. ISL 9237 includes a low power LDO with a nominal 4-volt output, which input is OR'd from pins VBAT and ADP, which is OR. Okay, VBAT or ADP, okay. VBAT or ADP, let's have a look. VBAT or ADP. So ADP, we have on pin number 16, we have double check our voltage. We're in voltage mode, which is that guy there. Okay. So it picks either VBAT, voltage battery, or adapter voltage. Okay. The ISL 9237 also includes a high power LDO with a nominal 5-volt output. Which input is from the DC in connected to the adapter and to the system bus through an external direct circuit. System bus. Both LDO outputs are tied to the VDD pin to provide bias power and gate drive power for ISL 9237. What's the VDD pin voltage on my pin number 18? $5, which is fine. When VDD is larger than 2.7, ISL digital block is activated and the SM bus register is ready to communicate with the master controller. When VADP okay. When a voltage ADP is larger than 3.2, so voltage ADP yeah, pin number 16. When voltage adapter voltage is larger than 3.2 volts after 1.3 seconds or 150 milliseconds debounce time set by control to register. AS gate start turning on. AS gate. Which is pin number 13. Okay, pin number 13. It connects to... I think I need to be really careful here. Here. Okay, let me double check. What? Okay. What I want to check is, in continuity, is that pin going to pin number 13? It is, okay. I just wanted to check that. And it says that AS gate starts turning on with 10 picoamps or microamps sync current during the 1.3 seconds or 150 millisecond debounce time. ISL 9237 uses Intersil's patent pending technique to check if the input bus is short or not. If CSIP, okay, here is our problem. Okay, this is the actual critical point. We may be able to fix this board. If CSIP is less than 2 volts, let's find CSIP, which is pin number 15. Okay, which is connected. We're in the voltage mode, yep. What? 14.68, okay. If CSIP is less than 2 volts, which is not, or AC in is less than 0.8 AC in, which is the one we're having problem with. It will not turn on. Soft start scheme will carefully bias up the input capacitors and protect the back-to-back ASCADE FETs against potential damage caused by the inrush current. Use a voltage divider from adapter voltage to set the AC in pin voltage. Use a voltage divider from the adapter voltage to set the AC pin voltage. AC in voltage, okay. I'm going to go back to my now schematics. I'm going to search for this AC in and find a voltage divider that creates okay. The only voltage divider I can see. Okay, what is this chip doing? NX3008 BKS dual channel enhancement MOSFET. Three, four, five. Now, did I replace that one? Is this the same one? No. Maybe I tested its pins and whatnot. I do remember removing it. Okay. I have the schematics for this MOSFET and I'm gonna check. Let's have a look. So the way my one reads is 1, 2, 3, 4, 5, 6. So gate 1, sorry, source, so pin number 1 is source and pin number 2 is gate. Okay, so check these two. Source. Okay, how can I check this guy and this guy? Source to gate, no short. Pin number 6 is drain of MOSFET 1. Let's check pin number 6 to pin number 1 and pin number 2. So here. Okay, now drain 2 is pin number 3, 4 and 5. Okay, let's check that. So 3 to 4. That's the second MOSFET. So in my setup, I only got this guy to go into ground. And only this guy. Correct. This one is 13.27 mega. Now, do I have one of these MOSFETs? I do. Okay, we do have it in Surface Pro 5 motherboard. Okay. Surface Pro 5 motherboard. And I'm just trying to locate it on this board. Okay, I've got a different board here. Nope. Shit, I'm looking at the Surface Pro. I should be looking at number 5, sorry. Okay. There should be one here too. Alright, found it. Alright, one sec. Alright, so we found another MOSFET. I'm still trying to locate it on the board. Okay, got him. This guy here. So let's go ahead and replace this MOSFET. So the dot being on the bottom left, bottom right. Okay, good. Okay. I think they're making contact, aren't they? Yeah, we don't want them to make a contact. Come on guys, let each other go. Okay, that's good. Definitely not making contact. Alright, let's see what happens. Do we have AC in voltage or not? We're in resistance mode. Let's go, voltage mode. Haven't plugged in the power yet. So we're going to check around there when we plug in the power. And let's see what happens. A charging light. We have our 3.3 on the always online. Nah. Nothing. No, nothing. So that MOSFET is actually good. So where else can this problem be? Okay. Pin number 3. Let's have a look at pin number 3. The data sheet says pin number 3 is drain 2. Drain. And source, which is pin number 4, and gate, which is pin number 5. So where is gate connected to? Gate is connected to 3 volt always online. Thank you. To a resistor 63059. Let's have a look at around there. Which is a 100k ohms resistor, which is right there. How the hell are you going to measure that? I don't know. Wow, 100k. We're spot on. We got that. He's fine. And goes into the 63,005. There's an A and a B. Oh yeah, yeah. So because they separated the MOSFETs in the schematics, I understand now. Yeah. Oh, thank you. Coming. Today, Shin. Thank you. Thank you. Okay. Okay. That's a 301k resistor. He's also good. Our problem is from SAM charger power supply on. That's our problem now. I'm 100% sure of that. which comes from U2701, which is on the other side. We can also check this resistor to see if there is any problems with that, which is going to be on the other side of the board. That's my last option. Which I think I focused here before. It's that guy there. It is 500 ohms, which is perfectly fine. This big chip is not telling him to turn on. He's not letting the power supply turn on. That's the thing. Sam, charger power supply unit on. It's not coming on. That's the problem. Now I understand what Sam means. Okay. Or a little bit at least. Okay. Sam. Let's see if 3.3 volt always on reaches Sam or not. Okay, just gonna plug in the power and gonna quickly check something on the height on this guy. Yeah, 3.3 is all here. No problem. And the other guys? Okay. Well, 3.3 should come here on top at least. Yeah, there we go. SAM reset. This is called SAM reset. Yeah, can't find the damn fault. So this guy is telling it not to turn on. That's the problem. There's an internal short somewhere. Alright. I'll have to give up on this one too. What an adventure. Okay. Alright. Off you go to your mummy. Alright, that will be the end of this video. I'll put this back together and finally I can close this job. Thanks for watching. See you in the next one.
Thanks for watching. Please subscribe to support this channel.